हॅलो फ्रेंड्स, आज आपण नवीन चॅप्टर चालू करणार आहोत. इंट्रोडक्शन टू पॉलिमर केमिस्ट्री. सो पॉलिमर म्हणजे काय हे अगोदर समजलं पाहिजे. सो पॉली मीन्स मेनी, ॲज यू नो. मोनो मीन्स सिंगल, डाय मीन्स टू, ट्राय मीन्स थ्री, and poly means many, and mers means small unit. So when many small unit combine to form a high molecular weight macromolecule, then it is called polymer. So polymers are high molecular weight macromolecules. They are formed by combining many small units. They either combine linearly or they combine in a branch structure, and it gives rise to a very high molecular weight compound, and it forms a macromolecule. That means a bigger molecule. Micromolecule means very small molecule, but all polymers are macromolecules because they forms a large molecule, a large in shape. So first part we are going to study is classification of polymer, but this part is not included in your syllabus because it is eliminated from your syllabus. But to know well about the polymer, let's study classification of polymer on the basis of its source or its origin. So polymers are divided into three categories: natural polymers, synthetic polymers, and semi-synthetic polymers. So natural polymers are the polymer which are obtained from either plant or animal source, or they are obtained from natural source. Again, natural polymers are classified into two groups. First is plant polymer, the fiber which is obtained from plant, for example cotton, jute, linen, or silk. Silk is the animal fiber. So such type of polymers which are obtained from plant origin, they are called plant polymers. Natural rubber which are manufactured from latex obtained from bark of rubber tree. So all these polymers are plant polymers. The second is animal polymer. They are obtained from animal source, for example wool from hairs of sheep, or silk, they are obtained from silkworms. They are animal polymers. Now second class of polymer is synthetic polymers. They are man-made polymers. They are artificially prepared in laboratory by polymerization process. Now synthetic polymers example is nylon, terylene, neoprene, etc. They are further divided into three types: fibrous polymer, synthetic rubber, and plastics. All are artificially prepared in laboratory, therefore they are called synthetic polymers. And third class is semi-synthetic polymers. They are derived from natural polymer. They are obtained by giving chemical treatment or heat treatment to natural polymer, and so they are not purely obtained from artificial way. They are obtained from natural polymers by giving some chemical treatment to them. Therefore they are called semi-synthetic polymers. Example is cellulose acetate rayon, cellulose nitrate, viscose rayon, etc. Now or cupra ammonium rayon. These are used in the preparation of non-inflammable photographic films or cinema films or varnishes, etc. Now there is one more classification of polymers. First is second classification of polymer is classification of polymer on the basis of structure. First we have studied the classification based on its origin or source. Now second classification is classification of polymer on the basis of its structure. And on the basis of structure, polymers are divided into two groups: linear or straight chain polymer. When many monomers or when many single unit molecules join together in a straight chain, resulting polymer is called straight chain polymer. For example, PVC, polyvinyl chloride, or high density polymer called HDP. And second class is branched chain polymer. When many monomers combine together to form a side chain or it gives branches, then it is called branched chain polymers. For example, low density LDP polymer. Third is cross-linked polymer. Cross-linked polymer when monomer combine together to form a network type structure, then they are called a cross-linked polymer. Example is bakelite or melamine. You can see here in a straight chain the polymers units are arranged in a straight chain M. But in branched chain the polymers have branches, and in cross-linked polymer are arranged in a network type structure. This this classification is already eliminated from your syllabus. But to study the further part, it is very important to understand the types of polymers. So I have just mentioned the classification of polymers. Now further we will study some important polymers which are useful in our day-to-day life. Now let us study some important polymers and their structure. The first is rubber, which is widely used. They are called elastomers because they are elastic in nature. They can be stretched or they can be compressed. Example, balloons, shoe soles, tires, surgeon gloves, garden hose, etc. are made from elastomeric material or rubber. So there are many types of rubber. First is natural rubber. Monomer of natural rubber is isoprene, that is 2-methyl-1,3-butadiene or butadiene. The structure of isoprene is given here: CH2 double bond C, CH3, CH double bond CH2. There is a double bond between carbon number 1 and 2 and carbon number 3 and 4. Therefore, the parent name is buta-1,3-diene, and there is a methyl group on carbon number 2. Therefore, it is 2-methyl-1,3-butadiene, but industrial name is isoprene. So natural rubber is made from this isoprene. When many isoprene units they combine together, natural rubber is a high molecular mass linear polymer of isoprene. Its molecular mass varies from 1,30,000 unit to 3,40,000 unit, and the monomer units varies from 2,000 to 5,000 units. So when these isoprene units combine together, they form structure like this: CH3, C, CH2, double bond CH, single bond CH2. Therefore, this double bond is converted into single bond, and it forms bond with another monomer unit. This type of unit goes on continuing, and this type of structure of natural rubber is formed. This is very important. You have to write this structure and practice this structure and write these notes in your notebook. The reaction involved in the formation of natural rubber by process of addition polymerization is as follows. When n number of isoprene unit combines, then polymerization takes place. That means many molecules they get linked with each other, and this polyisoprene is formed. On this polyisomer isoprene, this double bond is converted into single bond, and single bonds are converted into double bond. You can see here CH2 double bond C is converted into CH2 single bond C, and there is a carbon-carbon single bond in isoprene which is converted into carbon-carbon double bond in polyisoprene, and again C double bond CH2 is converted into C single bond CH2, and such units they continue on repeating. Many units they linked with each other to form polyisoprene rubber. This properties of natural rubber is polyisoprene molecule has cis configuration of the carbon-carbon double bond. It consists of various chain held together by weak van der Waals force of attraction. It can be stretched like a spring, and it has an elastic property. It gets stretched without breaking bond. So these natural rubbers are also called elastomers. Now, vulcanization of rubber. To improve this property of natural rubber, a process of vulcanization is carried out. The process by which a network of cross links is introduced into an elastomer is called vulcanization. So, this linear structure is converted into cross link structure, and this process is called vulcanization. And this, due to vulcanization, its strength, tensile strength, and stretchness, stiffness, elasticity, toughness, etc. increases. So, after rubber is vulcanized, its property changes, its elasticity increases, its toughness increases, and for vulcanization, sulfur forms cross-link between polyisoprene chain, which result in to improve its properties of natural rubber. So today we will stop here. In the next lecture we will study some other polymers. We will study their structure, their uses, etc. So today we have studied classification of polymers, and first polymer you have studied is natural rubber. Thank you.